Okay, welcome back. So we were just going to look at this CS production function. Now, obviously, once again, the optimality conditions are about, let me share my screen. The optimality conditions, once again, require the marginal productivities to be proportional to the factor prices, right? So if you look at the marginal productivities and if you take the ratio of them, you basically find this ratio. And if you equate this to factor prices, you realize alpha and alpha 2 are related with this. So here there is a trick. I want you to check the textbook for that trick. So what you want to do is to use this equation, all right? And then try to express this equation in terms of this ratio. So again, total payment to factor 1 and total payment to factor 2. For this, you want to multiply both sides of this equation by something like this or this. Okay, you should check that from the textbook. So then you're going to realize you cannot find alpha 1 and alpha 2 independently from rho. Okay, rho is the problematic parameter here. But if you assign a particular value to rho, then you can find a definitive relationship between alpha 1 and alpha 2. And in most applications, actually, we assume that alpha 1 and alpha 2 are equal to, sum to 1. All right? Then again, after assuming a particular value of rho, let's say you assume that rho is equal to minus 0.5. This is just a value. You can assume any value here, okay? But then you're gonna use this equation and that equation to eventually find. Of course, you have the ratio of total payments, and then you have the measurement, the change in the measurement units. So you express again all the data in the SAM. You interpret this data as quantity data by equating all prices to 1. And eventually, you find alpha 1 and alpha 2. All right. So this is in your textbook. I want you to check that. But basically, you see here, right? Because in the Cobb-Douglas case, remember, in the Cobb-Douglas case, you have alpha 1. You have alpha 1. You have W1x1. W2x2, and this was directly related with alpha. Now here, as you see, you have rho here and rho here, and it becomes nonlinear. So without knowing rho, you cannot identify alpha. Okay, so that's the type of identification problem that might appear in many different models, in many different contexts. In such a case, again, to achieve exact identification, you have to assume, you have to assign a particular value to the parameters that you cannot identify. So here, this parameter rho is not identified, so you assume a particular value, then you check through other means whether this assumption is reliable. This assumption is acceptable or not. You're gonna use independent observations for that. Okay. You're gonna use, for instance, other resources. You're gonna look at the literature. You're gonna look at micro evidence about the firms. You're gonna look at basically, if you know the elasticity of substitution, right? if you knew the elasticity of substitution, then you can solve rho from this equation. So if you have sigma, you can come up with some rho, and then you find alpha 1 and alpha 2. Okay. So again, just look at the textbook, chapter 6, I suppose. So it is explained there in much greater detail. So I don't want to spend so much time on this, but identification will appear in even in simpler models. Okay. So you will see that in the sample questions in one of the exams. Actually, I actually used a particular simple model that shows when there is exact identification and when there is no identification. Okay. So now, if you do not have any questions, I'm going to show you a particular example, and that at the end it will become your exercise for the next week. All right. So it will be a simple general equilibrium model, very simple actually. It will be two firms. It will be a model of two firms, two consumers, and one primary factor. Okay. But the interesting thing is that now firms will be owned by the households. Okay. And firms will make positive profits. Remember our toy model? Do you remember our toy model? In the toy model, remember, firms were price takers. The same will be true here, and firms would be making positive profits in equilibrium there, right? Even under competition, since there was decreasing returns to scale. So we're going to use an example like this. But the interesting thing is that consumer 1 will be the owner of firm 2, and consumer 2 will be the owner of firm 1. So these profits will be given to the consumers and will be part of their income. Okay, so let's look at this. Let's look at this model now. Let me open a new page, minimize this window. Okay, so so here we have two goods. Okay, these are goods. So we have production functions. Production functions are like this. So there is this technology parameter, and there's labor, and there's this alpha parameter. Okay, so theta is some technology parameter that is greater than 0, and alpha is between 0 and 1. Okay, now realize that since alpha is less than 1, this production function exhibits decreasing returns to scale. Right? Because if you increase, so if you increase labor input by some amount, this will be less than lambda y, right? So this is decreasing returns to scale, and it is all only because alpha is between 0 and 1. So there's a missing factor here, right? Now utility functions are like this. So we have two consumers. Okay, let's say A and B. Okay, so their utility functions are like this. So from the first good, this is beta A, and from the second good, this consumer A obtains this utility. All right, so here beta A is between 0 and 1, and for the consumer B, we have C1B, beta B, okay, and C2B 1 minus beta B. Okay, and beta B is also between 0 and 1. Okay. Now, if you want to write profit functions, so I was really sloppy here. Okay, so these consumers also have labor endowment. Okay, labor endowment, and these labor endowments are equal to 1. Okay, so these are labor endowments, and labor is supplied inelastically. So basically, they supply all of their labor. Okay. So profit. Let's write profit. So the profit function of firm I is written in this way. There is PI, right? Then there is theta I, Li, alpha I, right? And there is wage, and there is labor. You see? So now PI is the price of the good I, and W is the price of labor, because this is just one factor economy, right? So incomes now will be a little bit different. Income of consumer A will be equal to W plus pi 2. Okay, let me check. Yes. And income of consumer B will be equal to W plus pi 1. Why? Because consumer A or household A owns firm 2, household B owns firm 1. Okay? And finally, you will have the market clearing conditions, right? First, you will have labor market clearing, right? These consumers are in the meantime workers. They supply in total 2 units of labor, and firms will hire possibly both from these consumers, okay? Labor L1 and labor L2. So L1 is total labor demanded by firm 1, L2 is total labor demanded by firm 2, right? Then you will also have the market clearing condition for the first good. So it will be C1A plus C1B, right? And for the second good, you will have C2A plus C2B. Okay? So that's all. That's the model. Very simple. So you have a simple Cobb-Douglas utility function. You have the simple firm problem. So firms will only maximize profit by choosing labor. So you're going to find the labor from this exactly as in the toy model, that part. But then you will be careful with the definition of income, because consumer A is the owner of firm 2, consumer B is the owner of firm 1, so their income also depends on these profits. Okay, and these are your market clearing conditions. Now let's imagine the SAM of this model. Okay, let's imagine SAM. So you have firm 1, you have firm 2, you have the labor account, then you have household 1, household A. Okay, then you have household B, and there's no one else, right? So you have firm 1, firm 2, labor, household A, and household B. Okay. Labor, household A, household B. Okay. Now, first of all, you should be realizing that firms do not have input-output transactions, right? So firms do not generate income or do not make some expenditure to other firms or do not obtain income from other firms. Okay. Now firms obtain some income from consumers, right? Because they sell these goods. So typically you have P1 C1A plus P1 you have P1 C1A here, right? Consumer A spending P1 C1 for the first good, and here you have P1 C1B, consumer B or household B spending P1 C1B to first good. Then you have the second good, C2A, then you have P2 C2B. Okay. And of course, firm does not obtain any income from labor, right? So that will be 0. Now labor account obtain some income. Don't forget, incomes in rows, expenditures in columns. Okay. Now firm 1 will pay WL1 to the labor account, and firm 2 will pay WL2 to the labor account. Okay. Then labor account will distribute these, of course, to consumers, right? Consumer A obtain wage income W from the labor account, and consumer B obtains wage income from the labor account. Okay. So consumers do not obtain any income from themselves, but consumer A is the owner of firm 2, right? So the profit 2 is here, and consumer B is the owner of firm 1, so profit 1 is here. And then the rest is, of course, 0. Okay? Now, what I want, let me just check whether I have a mistake. Okay, as I see, there's no mistake. All right, so what I want to do now is to give you some numerical solution, some numerical data of the social accounting matrix. All right, so I will tell you particular numbers, then you're gonna check. You're gonna try to calibrate the parameters. So let's start with P1. P1 is equal to 56.999. I2 equals 31,350. Okay. Then let me open some space here. Okay. Then P1 C1A is equal to, let me be careful here. So P1 C1A is equal to 51 299, P1 C1B is equal to 34.2. P2 C2A is equal to 25.6299, and P2 C2B is equal to 68. That WL1, which is here, right? WL1 is 28 point that. WL2 is 62, 69, 86. And finally, W is equal to 45.599. Okay? So this is the entire SAM, right? Now suppose that this is these numbers are right. So we have P1, we have P2, we have WL1, we have WL2, we have W. We have W, we have P1 C1A, P2 C2A, P1 C1B, P2 C2B. Then you have the model, and the model is very simple. So you can actually solve the model. All right. Then what I want you to do is to try to calibrate the parameters. So what are these parameters? You have theta 1, theta 2. These are technology parameters. Then you have alpha 1, alpha 2. These are production function curvature parameters. And then you have beta A and beta B. Okay? You have 6 parameters. So I want you to try to find, try to calibrate these parameters using this model and using these using these SAM entries. You may not do it because these numbers. Okay, let me give you a hint. So these numbers originate from a solution of the model where I use this normalization. Okay, but I still want you to try. Okay, let's see how can you proceed, and then I will show you how to do it next week. Okay. So do you have any question about this model?
A little one.
Okay, go ahead.
I get it, and household one is the owner of firm 2.
Yes.
And gets profit from there. But is he work, and where is he work?
He can. Okay, so here is the idea. Okay, good question. So I'm both a consumer and a labor supplier. I have one unit of labor, Betül, okay, and I supply it in a divisible manner. So maybe I can work 0.2 hours for firm 1, my own, the other firm, and I can work 0.8 hours for my own firm. Okay, so it is divisible. It is divisible, but in total, I have one unit. So at the end, my wage income is equal to W, right? Because for one unit, I get W, either from either firm.
Thanks.
Okay, so that part. So if you let me just show to you again. So if you look at here, so if you look at the profit function of the firm, this is the labor demand by firm, and that labor demand in the market. So here is the market clearing condition. right? So firm 1 and firm 2, right? In total, this is the total market demand for labor hours, and this is the total supply. Okay, because we have 2 workers.
Okay.
Right?
I got it.
So you will find different. So you will find the solutions of different problems. Then you will be carefully identify from the SAM data here. Okay, you will look at the SAM data here and try to recover these parameters. Okay, as we discussed in the class in the last week and today. I want you to try. Let's see how you will proceed. Okay. I mean,
Okay.
which one of the parameters could be identified, which one of them are not identified, etc. I want you to explore these things by yourself as an exercise. Okay. The model is very simple though, right? Everybody's price taker, and excess profits are given to the owners, right? Exactly as in the toy model. Okay. So, any questions? Any other questions? All right, then. This is all for today. So, as I said before, I will post some readings, and then we're gonna see some environmental problem next week. I will show you how we can put environmental taxes into a simple model. Then we're gonna discuss those readings as well in the remaining weeks, and then that's it. Okay. So I'm ending this session now then, and see you next week.
See you.
Okay. Bye bye.
Have a nice day.
You too.